let's take a quick look at this question. In this question, we're asked to predict the sign of the, this symbol is entropy. Entropy for each of the following changes. Now, look at the various changes here. We are asked to predict the entropy change in this one. Now, remember, what we mean by entropy, we are looking at the degree of disorderliness or randomness of a particle of a system. All right, degree of randomness of a particle of what? A system. Now, for instance, let's take matter as a case study. Now, matter is has three physical states. We have the solid state, we have the liquid state, and we have the gaseous state. Now, the particles in the solid state are tightly packed in such a way that there is no random movement in this particle. But randomness, there is no degree of randomness in this system. Do you get that? If you look at this is solid. If you look at the one of liquid are a little bit they are not tightly packed as the one of solid. Now, if you look at the one of gaseous state, you see that, have you seen? This is how gaseous state is. So now the degree of this randomness, how the thing are scattered, is what we call entropy. Now we are asked to predict the changes, the sign of this equation. Remember, when entropy is positive, it means that there is an increase in what? Disorderliness. But when it is negative, there is a decrease in disorderliness of that system. Then when the entropy is zero, it means that there is no change. Now let's look at this question now. Now, how do you find entropy? Entropy is given as, this is the sign of entropy, is equals to entropy of product minus entropy of reactants. This is the, if you look at this one, what you are after of is to calculate the number of moles. Calculate the number of moles of product, calculate the number, minus it by the number of moles of what? Reactant. So here in the first equation, here this is the product. This product is what? Reactant. Now the product here, in the first one, the product here is what? We have 2 moles. Are you getting me? So the product is what? For the first equation, number 1, we have S is equals to what? We have 2 minus, look at the reactant here. Reactant, we have 3 moles of oxygen, we have 4 moles of what? Iron. So 3 plus 4 will give us what? It give us 7. So you are going to minus this one by what? By 7. So entropy here is what? Is minus 5. So since it is minus 5, there is a decrease in the randomness of what? The system. If you look at the second equation, you look at the entropy here. Here we have 2 moles. In the case of this one, we have S is equals to 0. So in this case now, the equation number 2, there is no change in what? Entropy. Since entropy is 0, then entropy number 3, we have here, we have nothing. So we have 1 mole. Here we have what? 1 mole. Do you get that? So 1 plus 1, we have what? 2. So entropy is equals to what? Entropy is equals to 2 minus, come to this side, this limestone. Here there is nothing here, so we have what? 1 mole of limestone. So you minus it by what? 1 mole equals to what? 1. So here the entropy here is positive because the value is positive. So there is an increase in randomness of the system. You get that? So see, anytime entropy is negative, there is a decrease in randomness. Anytime it is positive, there is an increase in the randomness of the system. Anytime it's 0, there is no change in entropy. Please and please, for more of this video, please do well to subscribe to my YouTube channel or follow me on Facebook on Ojemite Online Chemistry. Do well to like, share, and comment. See you in our next video. Bye.